50% early flood prevention and a 200 increase in elevation capacity over conventional models. In the case of delay of inundation, the prototype reached a condition of no ingress, which means that, unlike the 8 seconds flooding failure of the control, there was a total flooding ingress at this stage. The difference between the prototype and control model supports prior Philippine flood mitigation research highlighting the vulnerability of conventional ground fixed housing to flooding when adaptive mechanisms are lacking.
In conclusion, the results of this study demonstrate that buoyant foundation provides superior protection against flooding by significantly delaying water entry compared to conventional fixed houses. This delay offers critical additional time for residents to respond and ensure their safety during flood events. The prototype also confirmed the mechanical viability of the floating system. The vertical guide mechanism allowed the structure to remain stable and balanced as water levels increase, showing that small-scale floating residential designs are feasible under controlled flood conditions. Additionally, the rain garden component proved that residential housing can play an active role in flood mitigation. By absorbing and temporarily retaining water, the rain garden reduced the volume of surface runoff, helping to delay flooding before flotation becomes necessary. Overall, integrating the structural buoyancy with hydrological infiltration results in a more holistic and resilient household level flood defense system. This combined approach enhances both adaptability and mitigation, making it a promising solution for flood prone residential areas. Based on the findings of this study, several recommendations are proposed for future researchers, practitioners, and policymakers. For future researchers and students, further optimization of the rain garden substrate is recommended. Testing different ratios of sand, gravel, and organic matter may help to maximize water retention while preventing soil compaction. Mechanical improvements can also be explored and tested, such as adding tolerance gaps or ball bearing sleeves to the guideposts to reduce friction and ensure smoother flotation during rising floodwaters. And to address the erosion-related issues, future designs may add splash plates or river stones at water entry points to prevent soil displacement and substrate potholing. Standardizing the compaction process through a uniform stacking procedure is also recommended to ensure consistent and substrate density and reduce variability in
In terms of data accuracy, advanced monitoring systems such as water level sensors and ultrasonic distance sensors may be used to replace manual timing methods, allowing for more precise measurement of flotation behavior. Additionally, hydrodynamic testing using a water flume is recommended to evaluate structural stability under lateral currents and moving water forces. After technical improvements, community advocacy is encouraged. Awareness campaigns can help demonstrate how nature-based rain gardens reduce neighborhood surface runoff and peak flood levels, promoting wider public acceptance of such systems. For architects and engineers, it is recommended to test larger-scale prototypes such as 1:5 or 1:2 modules to better evaluate structural integrity and stability under real wind and water conditions. Finally, for local governments, policies that incentivize or subsidize households adopting integrated floating foundations and rain gardens are recommended. Such initiatives can support decentralized disaster risk reduction and strengthen community-level flood resilience.
For our acknowledgements, we thank Almighty God for the strength and guidance required to complete this work for the benefit of the community. Ma'am Joy Pavico, who guided the study and provided essential corrections to meet academic requirements and project development. Engineer Mr. Ray June T. Incencio, who assisted with technical understanding and methodology reviews to improve the research. Tita Lerma Palos facilitated the communication with technical experts, making the specialized parts of the study possible. Families and friends, who provided constant support and encouragement during the long hours of planning, testing, and writing. Thank you so much for listening.
Thank you for that very insightful presentation. Now, for our Q&A, we will be extending the time to 12 minutes. we will be extending the time to 12 minutes since the researchers have 2 minutes left from their presentation time. So here, we will take that with them as well. So, timer starts now. The floor is open for questions. Yes. Hello, researchers, but those of us, did I get it correct? Tama ba? Kasi, and then, so, first of all, congratulations, um, Raina, Sean, and Alexandra. So congratulations for presenting your project, flood control project. So this is quite scary. Development of flood response including house prototype with integrated rain garden system. So I was thinking you are only going to take a look at the floating house. However, you place their integrated rain garden system. So I have a few concerns in regards with your capstone project. So first and foremost, in the data that you are able to do, uh, you got a height of 10.57 and I wasn't able to catch the other table, the data in the table. However, if you are going to, I think you haven't presented also the picture of the house itself. You only presented the recorded video as well. So that will help us understand what type of what is the model itself, or what is the prototype. Hence, in the third video, that's the only time that I was able to see that how it was built. Since I think we use styro,
Yes, sir.
tama? Tama
Yes.
ba? So, you use styro, you use barbecue sticks, and then you are able to have it float. So, my main concern is if you are going to make this in real life, yes, it would float, but how about the foundations? How would you be using that one? So, or what are you going to use with those types of materials? So, I wasn't able to see it in your abstract as well. So, however, in your recommendations, that's a good it's a good one that you have presented the future directions of the research. But if I may ask, how is the absorption rate of the integrated rain garden system taken? How was the data from that one taken? How were you able to measure the absorption rate?
We measured the absorption rate, sir, before the flooding starts. Yung water level po, like, nasa rain garden, before po mag-flood and mag-leaf yung house, sir. We have formula for the absorption rate, Alex.
Did you use a formula for the absorption rate? Is that the Archimedes principle formula?
The formula used was V absorption equals V liquid minus the input water. Sure.
So how are you able to get the different values for that one?
Dun, sir, in our basin, sir, we have water level markers labeled how much water is left in the gallon. Yes, sir. Guys, help.
Naka-label, di ba? Sabi mo naka-label.
Yeah.
Lahat yun may label.
Can you mention it?
Po.
What was the formula, Ryan?
Absorption rate, sir?
Yes.
It's V over T. The formula I presented earlier was for the volume absorbed by the rain garden. Different formula naman po yung for the absorption rate.
My concern is how will we really get the initial data, the initial value.
Sir, for the values, for example, yung ml, sir, we use the automatic dispenser pump. Doon po sa gallon, we labeled like where is 500 ml, 1000 ml, 500 ml interval yung nasa gallon, sir.
So it's you only looked at the difference to get the absorption rate. When you talk about the absorption rate, isn't it that the soil itself absorbs the water? Isn't that your key concept or the key term? Because
Yes.
if you're saying that how much water would come in from the gallon to the tank, and then it's very visible in the video a while ago that it's oversaturated already. So that's not the absorption rate. That's just a transfer of water. Am I right on that one, or are we getting it in some other perspective? Alexandra, Tom.
For me po, sir, I would say that yung use case po ng rain garden po is to divert the water po. Kaso naka-enclosed system po tayo sa tank po natin. So, for sure po, magiging saturated po yung rain garden po. Kaso, in a real life experience po, the point of the rain garden is to divert the water to a sewage system or a different place po.
Okay, so there's a new idea now that the rain garden is supposedly diverting the water so that it will not overflow. However, this wasn't mentioned a while ago. 5 minutes. Okay, sige. However, in the beauty of the features of what you are, siguro, let's have this as part of your improvement and recommendation part. Kasi the paper is has the visibility to be a better paper. And then if the prototype is good also, however, we just have to fully polish it. Okay? Like for example, the heater absorption rate, some of the heaters should be clearer. And then the conclusions should be answering your objectives, mga anak, ha? So it shouldn't be looking into like for example, in other words, superior protection, mechanical viability. These are implications of your study rather than it's your conclusion. Okay? So keep that in mind, and then lastly again, your recommendations are good because it features and it focuses on the future directions of your research. So again, congratulations to others. I will be passing the mic over to
You have just over 2 minutes left, so we might only allow for one more question for those of us. Thank you.
Congratulations, Reina, Sean, and Alexandra. So, you did very well in scientific research. So, meron na akong few questions. Actually, big few questions. So, follow-up question ko dapat kay Professor Curly. regarding the absorption. So doon sa table here shows that there's 2,322 something ml of water that is absorbed by the rain garden, right? So, what happened to the what happened to the absorbed water? Does it get stored or does it slowly seep into the ground?
Since we use an enclosed basin po, the water was stored. But in real life scenarios, ma'am, the water can be absorbed by the ground.
Absorbed and then probably run off?
Yes, ma'am.
Or is there a possibility that it can be reused?
Pwede. Yeah.
Since it's a rain garden, so is there a possibility, Sean, is there a possibility wherein that absorbed water can be reused for another purpose perhaps?
Sean Rivera, you are rated.
Yes, yung absorbed water, pwede siyang gamitin for circulating nutrients and oxygen to cells.
John,
Everyone, we cannot hear anything, so just check your audio.
Hello, can you hear me po?
Yes, we can hear you.
So yes, the absorbed water can potentially be reused because it is stored within the rain garden substrate and may later be released through natural drainage or collected for non-potable uses such as irrigation.
last one. Do you think these floating houses could be built in real communities that we do? Remember, we have many areas where there's flooding. So, is it possible to build the floating houses in communities here in the Philippines? And what specific materials would you encourage the one who will make the houses, the floating houses? Is there any suggestion?
While this study does not intend to construct a full-scale residential structure, it serves as a critical proof of concept, ma'am, for architects and engineers to they may adapt our study and decide on the materials since they are the experts for future house design floating models with rain garden system.
Okay, thank you very much.
Okay, let us first give a round of applause for the floatables. Thank you for that insightful presentation and those very good answers. Now that our researchers have entertained those questions, let us not waste time and proceed to the second group. I would like to introduce to you our second group disciples, Ryan Baldosa and Leon